Hey guys, so today what we're going to do is talk about angles. We are going to be talking about the properties of angles, the key features of angles, and how to notate and identify angles. So to start, an angle is formed by two rays with a common endpoint. So I'm going to go ahead and highlight the word ray, and then I'm going to highlight the rays over here. So that's going to be ray BA and ray BC. And we call that common endpoint the vertex. The vertex. Now we conveniently also call the rays the sides. It's real super creative, I know, but it is what it is. Right? The way you name an angle is by using 3 capital letters, and the middle letter must always be the vertex. So we have 3 capital letters. Make sure you remember the middle letter is the vertex every time. You may use a single letter if there's only one angle located at the vertex. Otherwise, you must use 3 letters, or if they are numbered, you may use the number. When we are referring to the measure of an angle, make sure you use a lowercase m, followed by the name of the angle and its measure. So for example, here we have the measure of angle ABC is equal to 60 degrees. Now, if you're using the formula tool within our text in Kami, it will automatically put it in this font, so you don't have to worry about italicizing anything. There are 4 main kinds of angles. We have acute, which is, of course, any angle that is less than 90 degrees. So I'm going to go ahead and include that note right here. So again, we have our math tool, and I'm going to say less than 90 degrees. We have our obtuse angle, which of course is more than 90 degrees, so greater than 90 degrees. And then finally we have our right angle, which is of course an angle that measures exactly 90 degrees. So I'm going to say that equals 90 degrees. And finally we have our straight angle, which forms a straight line, and this is going to measure 180 degrees every single time. All right, so moving right along, we have an example here. Number 1, we're going to look at the picture, and then we're going to name the vertex, the sides, 3 different ways to name the angle, and then we will classify the angle. So first of all, the name of this angle is just the vertex. So we're going to look at that. Our vertex here is K. So K is our vertex. Remember, you have to use a capital letter for points. The sides of the angle. Now, there is a notation for ray, which is in your formula tool, and then you go to your pi symbol, and it's right here. Up close, it's not too bad right here, but the problem is it doesn't show up very well on this screen. So what I'm going to do is actually type the letters and then draw the arrow. Okay, so first of all, we have our side KL. We go from K to L, and we have K to J. Make sure that you do not switch those letters, otherwise you reverse the direction. So KL and KJ. And then what I'm going to do is use my shape tool to draw the arrow. So I'm using my line, and then I'm just going to draw the arrow from there. And it's not going to be perfect, but it is going to be visible. All right, now there are again 3 different ways to name this angle. Since there is only one angle, in this instance we may use just angle K. And though more accurately and more consistently, the 3-letter combination is going to be used. So we have LKJ. Again, we start with L, we go to K, we go to J. it's important that you put them in the right order. And this one can also be JKL, because it doesn't matter which way you go, as long as you're following along the correct letters. So JKL and LKJ are the same angle because they have the same sides. And although we normally would not want to eyeball an angle, we can look here and tell they wanted us to say this is an obtuse angle. If we were to measure it, I believe it comes out to approximately 135. Let me check. Let's see. So this is my 0. We come down here. 90. I'm going to line up with that line. So this is 90. We're going down to 47. So, all right, so 90 minus 47 is 43, and then we add that to 90 to get 133. So this is a 133 degree angle. All right, moving on. We are going to look at example number 2. It wants us again to name the vertex of the angle, which is right here. Okay, and that is point S. Remember, for points, we just put the capital letter. The sides of the angle are going to be the rays, so that's going to be ST and SR. And again, like I said in the previous one, I am just going to draw the arrows for the rays, because again, I feel like the correct one, or the official one, is hard to see. You are, again, more than welcome to use the official one. That is up to you. My arrows may not be pretty, but like I said, I can see them. That's a good one, though. All right, 3 different ways to name the angle. Again, since it's a solo angle by itself, we can name it simply by its vertex, which is S. The other 2 ways we can name it is by saying angle TSR or angle RST. Remember, again, we can go the same order so long as, or opposite order, so long as the vertex is in the middle. And because they give us the little box here, it does mean it is a right angle. Now remember, unless they tell you specifically that 2 things are perpendicular or they give you the right angle marking, you have to remember we don't eyeball that. The difference between a 98 degree angle and a 90 degree angle is very minuscule. So do not assume it's a right angle unless you're told to. Right, the definition of congruent angles is going to be if the measure of angle A is equal to the measure of angle B, then the angles are congruent. This is written as angle A is congruent to angle B. So you can see here we have 2 75 degree angles. Now the next one, it says angle bisector. We are going to talk about a ray, and often it will be a line, but once it hits the vertex, we look at it as a ray. So a ray that divides an angle into 2 congruent angles. In this diagram, ray BD is the angle bisector, so that means angle ABD, which is this angle here, and angle DBC are congruent. Okay, and again, we can tell that because we are given this arc mark right here, and it goes across both angles. So that indicates this is a 1 arc mark angle, this is a 1 arc mark angle, and together they can be double the size. Next up, we have perpendicular lines, again reminding us from the vocabulary we did the other day. 2 lines that intersect at a 90 degree angle. The symbol for perpendicular looks like an upside down capital T. And in the diagram to the right, we see that line L is perpendicular to line M. And that's how we read that. Line L is perpendicular to line M. Now, when your segment bisector happens to be perpendicular, it also makes it an angle bisector. So a line, segment, or ray that is perpendicular to a segment at its midpoint. in the diagram to the right, line LM, and it looks like my line has disappeared, so let me go ahead and add that back. I most likely accidentally erased it. So line LM is the perpendicular bisector of segment PQ. All right, so let's go ahead and look at a couple of examples here. Example 3, write another angle, name for angle CBF. Now, on none of these can we just say angle B, because if we look here, there's 1, 2, 3, 4, 5 clear, distinct angles, which can also be added up into 6, 7, 8, 9, 10-ish angles, including the straight angles. So we definitely do not want to just say angle B. If you say angle B, it's which angle B? So let's go ahead and look at these different angles. So we have angle CBF. It wants us to find another name for it. So CBF is this angle here. So the easiest way to rename that is to just flip the letters. So that's going to be angle FBC. Now it wants me to name the sides of angle EBD. So again, I'm going to go ahead and highlight it. EBD. And to do this highlighting, I'm using the drawing tool. So our sides are BE. And remember, order matters for rays. And BD. All right. Excuse me. So I'm going to draw my arrow above it. Must have an arrow. And again, remember the end point always goes first. Next up, we're going to classify angle ABC. And if we look at angle ABC, we will find that it is a straight line. So that is a straight angle. Type that in. Oops. Okay, now it wants us to give an example of an obtuse angle. There are a few of them. The most obvious one that they're going to suggest is EBC, but we can also compose a few. We have EBD and ABF. You would only have to give one on an assignment or a test unless you were asked for all of them. But for this one, you only really need one. I am going to put all the answers so that it is obvious that there is more than one answer. But for the purposes of the notes as what's required, you only have to give one solution each time. Okay. It says name two congruent angles. There are actually a couple of options here. I'm going to go with the most obvious. So the first obvious one is angle ABE is congruent to angle FBC. And we know that they are congruent because they have the identical tick marks. So if we look here, we can see ABE right here and FBC have the same arc mark. Okay. The other congruent pair is going to be a set of right angles. We have ABD and we have DBC. Okay. So that is our other pair. So angle ABD is congruent to DBC. Angle DBC. And then the only perpendicular bisector we have in this image is going to be DB. We can see that AB is congruent to BC. they have the identical tick marks. So then that means BD, which is perpendicular to AC, is going to be the perpendicular bisector. So it is going to be BD. And remember, that is a ray. So we need to draw the arrow on top. All right, last problem here. Again, we don't want to say T is angle T for any of these. It is the vertex here for angle 2. Okay. So we have angle 2 right here. All right, so angle T. Again, remember capital letters. Name the sides of angle 4. And this time I'm going to keep the coloring under control. So angle 4 is right here. So our sides are TW and TZ. Remember, the T needs to go first because it is the vertex. And again, it is a ray, so we need to make sure that we include the arrows. One arrow for a ray. Do not forget the arrows. All right, another name for angle 3. Let's take a look at angle 3. There are a couple of options. Again, you only have to give one, but I'm going to give both. So the two options are angle UTZ or angle ZTU. Okay. Next, it asks us to write another name for angle 1. Okay. Again, that's right here. So another name for angle 1 is going to be angle YTX and angle XTY. Again, one answer choice is adequate. All right, let's go ahead and look at angle YTW. So YTW, oops, I said that backwards, YTW, it's that angle, I apologize. All right, and that's going to be a right angle. We can know that because it has the box. Now, we have the box here, so if it's 90 degrees and it forms a straight line, that means this is also a 90-degree angle, this is a 90-degree angle, and 2 plus 3 is also a 90-degree angle. All right? So next it wants us to classify YTU, so that's YTU. And again, I said angle 1 is a right angle. Angle 2 is an acute angle. When you add anything to a right angle, you end up with an obtuse angle. Up next, we are going to examine angle XTU, which is right here. And like I said just a moment ago, that's an acute angle. It happens to be 45 degrees. We can tell because it is a bisected right angle. And WTX is going to be a straight line. So we call that a straight angle. Okay. We have named 2 perpendicular lines. There's only 2 lines on this page or on this question. It's WX and YZ. You can put it either order. You can put XW, you can put ZY, you can put the T in there if you wish, as long as you put 2 of the letters and the line underneath. I do tend to stick with the letters that are at the furthest end, so just the furthest points on the line that are given. I feel like it's just easier that way, but you can do it however you wish. Remember, there's 2 arrows on a line, so what that means is there's also 2 arrows on the notation for a line. So make sure that you don't just do like a ray, you have to put arrow on both ends. And yes, I know these aren't very pretty, but I'm using a mouse. Okay. And last, it wants us to name an angle bisector. Now again, I'm pretty sure that what they are looking for here is for us to identify TU, and that would be a correct answer. So I am going to put that as the answer. However, you'll notice the instructions asked us to find or name an angle bisector, which implies the presence of more than one. So if you give it some thought, you will realize that because these lines are perpendicular to each other, a straight angle has a 180-degree measure. That indicates that YZ is bisecting the angle WTX. Or you can always say that WX is bisecting angle YTZ. That is a technically correct answer, and I would accept it all the time. So just keep that in mind. But for now, that's everything I have for you. I'll see you next time. Stay safe.